Swayam Prabha. Digital India. Educated India.
So, good morning. This is the lecture number 37 in our the architectural acoustics NPTEL course. Welcome to the lecture. Welcome to this lecture. We will discuss about the environmental acoustics also in this lecture, as the lecture topic says this is environmental acoustics 2. So, if you remember in the previous lecture we have just the figure out and the outlined the particular the acoustical phenomena which actually impart or the sources which actually impart the noise and the noise pollution in the environment. So, in this particular lecture also we will go into bit of detail and also we will try to do some kind of the indexes for the noise exposure and all. So, that will be demonstrated in this lecture as a lecture objective or the learning objective, and also we will categorize the ambient noise, what are the different types and how it will be actually functional in those the type of ambient noise. So, if I go with this ambient noise, this is defined as it means that it is a kind of a background noise which sustain for sometimes or maybe a longer duration. The time is also very important of course, and its presence in a specific area, and it is kind of a geographical area or maybe sometimes it is also specified in and around a surrounding a built environment, or it may be a community, or it may be sometimes industry, or it may be a kind of a, suppose if you take a the shopping area or maybe a bazaar or kind of a market area, those are another area. So, what is the ambient noise level of that area? So, that is the particular geographical conditions which may or may not have that kind of the built environment, but it should have some kind of background noise presence, and duration is also important, maybe for a smaller duration of the time or is sometimes for a whole day or whole night also. So, those are the typical the definitions or the which we can start with ambient noise. But ambient noise, if you just go and if you just think or if you just remember, this ambient noise are time specific and also the nature specific. That means, it has three types as such. One is called a continuous noise, ambient noise, and one is intermittent noise, which is not continuous, but tend to be a continuity, having kind of a continuity, and the third one is not at all continuous, which is impulsive kind of a noise, which is a noise which comes sometimes in some uncertain way, or sometimes it may not come maybe in a day sometimes. So, it is with that particular definitions and with that particular ambient noise classification, let us discuss this three type of the noise, ambient noise. The first one is continuous. As you know, continuous meaning is without interruption. So, this noise comes almost in a same mode of frequencies or same group of frequencies, and it is actually uninterrupted from the timeline point of view, uninterrupted, and also almost similar amount of the sound pressure level which exists. So, almost everything is similar, the time specific, it is not time specific, it is a continuous, it is not frequency specific, it is a kind of a band of frequency which go for a longer duration of the time. So, you require some kind of a manual equipment to, for some, suppose you just go for a testing for those particular or the recording those particular noise and try to measure that particular noise. So, you just spend some minutes of time and find out what is the total level of the sound. So, it's looked like this, it's very steady kind of a the SPL level, and if you just frequency, if you analyze also, it will be some kind of a steady. So, the examples are some kind of a blower, some kind of a pump, the same kind of the mixed frequency comes in a specific longer duration of the time. Intermittent noise. Intermittent noise is that which is tend to be continuous, it is a kind of a continuity, but there is some the gaps or some drops. So, it operates for some certain time, which in that there is a plateau kind of a thing, and then it drops, and then again it goes like that. So, to measure this particular sound, you require a longer duration, little bit longer duration time, and for those specific 2-3 hours time, it is of course depend upon the source specific also, and you take that particular duration for the measurement for those duration, longer duration, and then analyze that one. It is look like this, it is some steady portion, some time, this particular time it exists, then there is a drop, and again it goes. So, you need at least some longer duration measurement, and then you have to find out what are the, if you take a very small duration measurement, suppose your measurement duration is here, you cannot actually sense the actual measure, or you can actually do not will not get the actual measurement also. So, you have to actually see the longer duration measurement. Periodic running of machines, specific traffic rush hour is another, suppose it is morning some 8 to 10:30 or 11, and this is evening time, and in the afternoon time it is little bit low because of there is no traffic in the road. Some a train movement or those kind of a thing, and of course, the landing and the takeoff or some kind of a aircraft, which is also that kind of a specific. The last one is the impulsive noise. Impulsive noise is kind of a noise which operates for a few seconds or maybe a very few seconds, and it is very much uncertain when actually it will be going to occur, unexpected. So, its monitoring also very tough, because suppose for a full day there is no such noise, but there may be a day where there are 3 or 4 such noise going to be maybe happen for that particular area. So, you manual operations, manual recording is impossible. So, you require a kind of a data logger, we equip data logger, digital recording machines and data logger, which can take for longer period of data, and after you receive those data and you analyze, then what is the peak values also. It sometimes look like this. So, there is a very few second, there is a this huge or the high amount of noise, and for a longer duration there is no, and the occurrence of this is also unexpected. So, suppose there is blasting of mine, in the mine there are blasting, some punching machine operation, gunshot, those kind of thing, or I may say suppose the very high speed bike that moves in a particular road gives a very tremendous amount of sound, but it does not move, sports bike or those kind of thing which may not move very frequently can be maybe an example of impulsive noise also. So, as we understand from the earlier 3 slides, it is not only the amount of noise, that is the SPL of the noise, it is not only the frequency of the noise, and also the character of the noise and the source and all those kind of thing. It is one of the important the character of the urban noise or the environmental noise is that is exposure time, it is very much time dependent. So, suppose a very high level noise of suppose 90 dB or so, its act for a very few seconds, it may not give you that much amount of impact in your brain, but suppose a little bit of lower decibel level, maybe 65 decibel level sound stay for a continuous period, continuity. So, that particular noise maybe for a half an hour or so, that particular you are exposed to a particular that particular environment 65 dB noise or so may give you very much problematic from the point of view of the health or so. So, the noise exposure, how much time you are exposed to noise is also important. So, what we have seen in the earlier lecture is that I am going to find out the average and the total amount of noise and the A-weighted noise also, which now in this particular exposure point of view has to be taken in consideration with the time. So, what frequency and which amount of the decibel level stays for how much amount of time. So, time factor has to be also embedded or the inbuilt with this particular the index system and find out the what is the total noise exposure. So, I have told you if this is the characteristics of the SPL and the noise, some is stay for a longer duration, some is not stay for a longer duration, but the total SPL level is very much peak is very high. So, maybe this is problematic, this may not be this may not be. So, how I can actually now club the SPL and the time. This is the fusion between the SPL and the time is required for this kind of the noise exposure. So, what we can do is that we can actually find out the continuous sound level, which is equivalent continuous sound level. A noise may be a beep and again after some time there is a beep and again there is another beep. So, each high level noise stays for how much and then let us convert that to equivalent continuous sound level. It has been done with this various specific sound level and the specific time duration point of view, and this formula has been given like this: the L equivalent, which is a time dependent phenomena, is T1 into 10 to the power L1 by 10. This 10 to the power L1 by 10 we have already experienced in the last lecture, and that has been multiplied by T1. What is T1? The T1 is the exposure time of the L1 sound. So, some source of sound having a L1 SPL level stays for T1 hours. So, this will be the cumulative effect, exposure effect of that particular sound. This is the cumulative exposure effect of the second source of the sound, third source of the sound, like that. You add it up. After you add it up, make the logarithmic of that big number, multiply by the 10, very usually what we did in the log the totaling of that particular noise level, and finally after multiplying by this by 10, divide this 1 upon capital T, and this capital T is nothing but the hours time, which is equal to this exposure time, the arithmetic sum of the exposure time. So, I have suppose measured some 75 minutes noise sample in any locations, maybe industry. So, it has 60 dB and that stay for 30 minutes. This 30 minute may not be a continuous 30 minutes, this may be a 2 minutes and then there are again some gap of, then there are some 70 dB or 70 dB for 2 minutes and then 85 dB for 1 minute and then again 60 dB for 5 minutes, something like that, ups and downs. But totally this 60 dB stays for 30 minutes and total amount of 70 dB sound stays for 20 minutes, 85 dB is for 15 and this 90 dB is for 10 minutes. So, I need to find out what is the L average and the L equivalent. The L average I know, I have already done this in the earlier lecture. So, all this by 10 and then logarithmic 10 to the power of that big numbers, totaling of that big number is a huge number and this huge number is divided by 4 because there are 4 the data set or maybe the 4 observations, and I am getting around 85.2 dB is the average sound level of that particular situation, which, but I have not taken any exposure time into account. So, next what I will do, I will go for the L equivalent, which is I am taking the exposure time into account. So, this particular that particular table is expanded. Now, T are also mentioned over here in minutes and T is also mentioned in hours, and this T in hours is multiplied with the respective 10 to the power L and then this number are created, and again you have to add it just like this. You have to add this T 1 multiplied by 10 to the power L 1 by 10 this number. So, there is a huge number, and this has to be next is the logarithmic of that into 10 is 83.97, and that has to be divided by capital T. The capital T is nothing but this plus this plus this plus this, which is 45 minute. I am sorry 75 minute, and the 75 minute is nothing but have to be converted into the hour, which is 1.25 hour. So, finally, this is the result, this L equivalent is 67.1 decibel. That means, if you are exposed to 60 dB sound level for 30 minutes, 70 dB for 20 minutes, 85 for 15 minutes, 90 for 20 minutes, is almost like you are exposed to that 75 minutes in a sound environment equivalent to 67.1 dB. So, the noise exposure has been taken into account. Then there is another way people has looked into it, is called as a LN concept, that is the LN is 3 L's, the levels, and this is how much noise is the above of that particular level. So, suppose if I say L is 30 is 75 dBA, this A weighted scale point of view, that means the 75 dB represent this L 30 equal to 75 dBA, represent that the 30% of the measurement time 75 dB the noise was more than exceeded the 75 dB. So, similarly, there are 3 such levels has been considered, the L 10 amount of sound dB in dBA that exceeded 10% of the sound, 10% of the time, and L 90 is the 90% of the time how much sound is exceeded of that particular level, more than that level, and L 50 is the average. This is the median point of view, the 50% of the time how much is the more than that particular level. So, let us I have 20 noise sample data I have obtained, suppose from a bus busy road station junction, and those are the data number 1, 2, 3, 4 to 20, and those are the SPL level of those particular, and I want to find out these 3 levels L 10, L 50 and L 90. So, what I did a birth diagram. So, those 20 data and this SPL. So, this is first one is 43, 81, 25, 66 like that. So, some of the very high, some of the very low, some of the in the medium category, medium range. So, I plotted those particular thing, and I know that this is I have 20 data. So, 10% of the 20 data is 2, and so this 2, the highest 2 are 81 and 83. So, the L 10 is this line, because everything is more than 81, I mean 10% of the time is the sound level of that particular data is more than 81 decibel. Very similarly, 90% of those 20 is 18. So, if I draw a line over here, these two 19 and 17 are below. So, those 18 are above this 90 line. So, I can say this L 19 is 21 decibel, because 90% of the all the data or the all the time, I mean all the these things, the exposure are more than 21. Similarly, I have drawn another line over here 50, because 50% of 20 is 10. So, if you see above this particular line there are 10 dots, and below this particular line is 10 dots. So, I can say the L 50 is 38, because 50% of the time the noise is more than 38 or more than that. So, L 50 is 38, L 90 is 21, because 90% of the time is either 21 or more than that, and L 10 is 81 because the 10% of the time the total of the total it is more than 81 or more than 81. So, 81 and 83 are above that. So, how can you easily do that? If you have this data, you sort that data in the descending order. So, from the highest to lowest. So, you know this is the sample is 10 sorry 20 samples. So, this is 2. So, the 81 will be the take 2 upwards. So, 81 will be your L 10, this 38 because this is the total total 10 numbers dots above that. So, 38 is the L 50 and this 2 are below 21, 22 are below. So, this 21 is this one. I think this line has to be shifted little bit here. So, this it is more than 21 is more than that is the 90% of the level or so. So, from this point of view the traffic noise index has been derived, which is given as this TNI traffic noise index is this with this formula 4 times L 10 and L minus L 90. What is this L 10 and L 90? The upper limit and the lower limit, this between this particular upper limit and the lower limit, this range gives you the range between the L 10 and the L 90, the fluctuating noise between these two particular point plus L 90 minus 30, and this total has to be expressed in dBA. Why it is L 90 minus L 30? Because L 90 what? L 90 is not the upper limit, L 90 is the lower limit. So, L 90 is referred as represent the background noise. So, that means the L 90 is the lower 10% and the all 90% of those are above that. So, you can say that this particular noise level always going to be there. So, that is the background noise. So, this the second part of this equation confirm the background plus the first part of the equation confirms the range, and that gives the TNI index of a traffic noise index. Very similarly, you also there is an index called the noise climate. Its the relation is this difference between this is range L 10 by the minus L 90. So, if there is a kind of a timeline SPL given for a particular the noise source or maybe a mixed noise source. So, you have to find out what is the L 10 and what is the L 90, and the difference between them L 10 minus L 90 is the noise climate. So, you can actually understand what is the you remove the top 10%, you remove the bottom 10%. So, the middle 80% is within what zone, it gives you kind of indication what is the fluctuation of the noise climate or the noise you are exposed to or a particular area is exposed to. Then next is the noise dosing. This is also very important, sometimes it is very important from the industrial noise point of view. It says that it is as it is defined as or the noise dose is how much noise and how much duration, what is the time duration of that noise, both are taken together for a particular the level. So, what we have seen in the equivalent L equivalent, it is the totaling, it is the totaling of if you have n number of SPL level and those n number of SPL level have T1, T2, T3, Tn, then it gives you a kind of a average scenario what should be the actual equivalent level of the noise for those timeline. But here it is not for the different noise level, it is for a particular single noise level, and single noise level is exposed for that particular time. So, it is particularly very much important for industrial noise calculations also. It is what you have given here is that, or what is the benchmark is that a time weighted noise level for 85 dBA for 8 hours period is taken as a 100% dose. That means, if I am exposed to 85 dBA sound for 8 hours, morning 8 o'clock to evening 4 o'clock, 8 hours, I am exposed to that particular noise, 85 dB noise, and that means that particular total amount of the noise exposure to me is almost about 100%. And suppose next day I am exposed to 90 dB or maybe 95 dB noise, but for only for 1 hour. So, definitely what will be the corresponding change in the noise dosing? It will not be definitely going to be 100%, it may be less or maybe more, because of the 90 dB is more and again the time duration is less t. So, how that can be calculated? It can be calculated by this simple equation 100 into T by 8, where T has to be mentioned in hours, and this is L equivalent of that particular noise level minus 85 divided by 10, and that will give you a percentage dosing. Suppose if you just put, I mean I think I have it in the yeah, I have it in this particular format, this particular slide. Suppose I have SPL levels 79, 82, 98 like that, and all are having suppose exposed time of 8 hours duration. So, the suppose a case of suppose I have taken 85 and 8 hours. So, I put T, capital T as 8, and this T, if you just go through the earlier slide, this T and this LEQ has to be changed. So, here this is 85 minus 85 by 10 is 0. So, 10 to the power 0 is 1, and this 8 by 8 is also 1. So, it is 100, and so that is 85 dB, and for a time of 8 hours is equivalent to 100% of the dosing. So, this 100 and this 100 and that particular point in this graph is 185 of 8 hours, and this is 100. And next is suppose I am exposed to a 91 dB sound, and also I am exposed for 8 hours for 91 dB next day. So, what is my equivalent dosing on that particular 8500% dosing? So, I just put 91 over here and minus 85, which gives me 10 to the power 0.6, because 91 minus 85 is 6, and this 8 by 8 remain 1 and this 100. So, it gives me almost 398, almost 400. So, if I expose to 91 dB sound for 8 hours, my noise dosing is almost 4-fold, 4 times. So, this is over here 400. So, this graph shows from a 79 to 98, I have drawn this blue color and shoot up, it is this the fold is shoot up, I would say logarithmic increasing kind of a scale, it is exponential kind of a scale. So, even that gives a particular understanding or that a high level noise and for a minimum time or small time is almost equivalent to a low level noise of a high amount of time exposure. Next, what I did is that I have kept this SPL level same. So, just reverse of this table where this SPL changes, time has been kept equal. Here the SPL is kept 85 itself, and time is now I am varying from 16 hours to almost 1 hour, and as you know the 85 with 8 hours is 100, which is the correspondingly is the benchmark. So, let us calculate if it is 85 dB and for 4 hours. So, then this T become 4 and this 85 minus 85, this will be 0, 10 to the power 0 is 1, this is 0.5, so 50. So, it is from 8 hours to 4 hours is drastically dropped by half, and if you see it is a T is a linear, T is does not come under 10 to the power. So, you will get a very linear graph, If it is 16 hours, which is twice of the 8 hours, your noise dosing is twice of 100, that is 200, and if it is 1 hour, that is 1/8 of your duration of 8 hour, which is 1/8 of 100, which is 12.5. I have just make it as 13, 12.5. So, it is a very linear kind of a graph we will get. So, that is the noise dosing, which is one of the another index, noise index. the noise dosing. Now, let us have a noise dosing of two different noise having two different time. Suppose L equivalent, if it is for first 4 hours is I am exposed to 80 dB sound and the last 4 hour I am exposed to 90 dB sound. So, with this I can find out this first 4 hours of 80 dB and then 90 dB, and then I can calculate this is all 0.5, this is 10 to the minus 0.5 and 10 to the plus 0.5, and finally, I can find out this noise dosing is 174, that is the dosing. So, ambient aircraft noise is also one of the issue nowadays, and this particular noise is monitored by the civil the Airport Authority of India, and those noise can be carried out where this particular airport is as per our CPCB that 50,000 aircraft per year, and that particular strip or maybe this airport has to be taken under consideration, and for that a DNL, that is the day night average sound level has to be considered for that particular thing, where the L equivalent has to be measured for the 24 hours period with 10 dB penalty for the night time. I will explain that in the next slide. So, this time duration, night time duration is the 10 p.m. to this 6 a.m. this night. So, this DNL total is given by this formula, where this equivalent noise level for the day, which is this the equivalent awaited sound level for 1 second in a day, equivalent for 1 second in a day, the impact is of 1 second, because in a day for 6 a.m. to 10 p.m. in dB. So, it is taken care of the impact of the sound or impact of the time, and also the equivalent of the night is also taken care of, and that is also taken care of, and that time duration is 10 p.m. to 6 a.m. because as you know the airport, which airport are actually taking care of the 50,000 aircraft, passenger aircraft per day, is definitely the whole day and night there are some takeoff and the landing is operation is there, and as it is for the night it has to be taken a penalty. I mean, you have to take a 10 dB plus with this particular number, which is actual number, which is actual the measurement from this airport, plus 10, the 10 dB penalty applied for the night time only, there is no penalty for the daytime, and this total period of the time in consideration in second, that how much second you have considered for this particular time data, that has to be taken into account. This the L equivalent for how much period of the time duration has to be taken care of. So, at the end of this particular lecture number 2 of our environmental acoustics, again I have some homework for you. Thus are some theoretical questions. Thus, what is the differentiate with the example the various forms of ambient noise with example, and the second one is that the estimate the noise climate and the traffic noise index, that is TNI, with this following data. If the L10 is 80, L50 is 60 and L90 is 40 dBA. So, find out what is the noise climate and what is the traffic noise index. For this particular lecture also I have consulted the similar books with some publications available in the net from the Central Pollution Control Board, New Delhi, and our National Building Code, and those one books of the acoustics in built environment. So, thank you for joining in this lecture. Lecture number 37 ends here. Thank you.